Welcome back, everybody. We are going to do 4 graphs today. I know it says reciprocal graphs, but we're also going to throw in tangent and cotangent. When we graph the reciprocal functions, cosecant and secant, we're really going to graph sine and cosine. So in that respect, it's not going to be anything different or new. We're just going to do the reciprocals. So we're going to go through cosecant very carefully, and then the others will go much more quickly because the same kind of patterns apply. So how are the cosecant and the sine, how are they related? Of course, they are reciprocals. All right, so we know we flip one over to get the other one. So if we think about some values, the sine of 0 is 0, the sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and 2 pi we're back at 0. The other ones are difficult to flip over, so we're not going to pay too much attention to the radicals. Now we know, of course, this is radical 2 over 2, which is right around 0.707. We've talked about that before. And when you flip that over, you get plain old radical 2, which is right about 1.4. So if we need those, we have them. So let's talk about the main ones, the ones in the zeros. These are the ones we only graph anyway. So when we think about the reciprocal of 0, and we've done this with the unit circle, this is undefined. What does that look like on the graph? We'll get to that. Reciprocal of 1 is 1. We're back to undefined. Reciprocal of -1 is just itself. And then, of course, we're back at undefined. So we have lots of places where the graph is undefined. So in order to graph the cosecant or any reciprocal, we are going to graph the one we are good at. So we're good at sine, we're good at cosine. That's the one we're going to graph. And we're going to put that on our graph, and then we're going to do the reciprocal right on the graph. So if we think about, this is going to be y equals, this is going to be the graph y equals the cosecant of x. I got rid of the directions, but that's the one we're graphing. So before we do that, we graph sine. So if we graph sine, we know that sine has a 0 beginning, middle, and end. Now we know we're looking at 2 pi. We also know that the sine goes up to 1 at pi over 2 and down to -1 at 3 pi over 2. And we have the values over here. This is not the graph, right? So this is the graph of the sine, and I'm just going to back some of these up, -pi over 2, -5. I'm just trying to fill in the space. So this is the graph of the sine. And I'm going to draw like a dotted line because it's not really what I'm trying to draw. The graph of the cosecant, I'll do that in blue. Let's do the reciprocals right on the graph. Any place there's a 0, it turns into undefined. Undefined will be an asymptote. So any place where it's a 0, the reciprocal turns into an asymptote. You must draw these asymptotes on the graph. Now, the rest of these are a little bit hard to see. So at pi over 4, we talked about how it's like 1.44. So at pi over 4, it starts to go up. We know this is a point, so we know at 3 pi over 4, it's kind of the same answer. It's going to look like a parabola. It's not parabolic, but that's what it looks like. So if we have the base or the minimum, that means we know that this curve is going to curve up. If this is down here, then that turns into a maximum. And then this curve is going to curve down. And this curve, same thing, curves down. If you have a place where there's half, and that will happen, like over here, I'm over here, you would just draw half of it. You only draw the curves where you have an asymptote. This will become easier when we do this again the next time you're in class is when we'll do it a second time. So that's kind of what it looks like. So it is the blue graph that includes the asymptotes. The black dotted line I just used to sort of help me sort of figure out what's going on. So let's dissect this a little bit better and look at its parts. So if we take a look at this, how do we locate the vertical asymptotes? Well, the asymptotes are where sine equals 0. So if the sine is 0, then it turns into an asymptote. So I already sketched the graph. The period would be all the way over to here. So So this is the period. We need an entire curve going up and an entire curve going down. And we'd like to start with sine because it starts and ends with an asymptote. Not all of them do. So our period is definitely 2 pi, which is nice. Our vertical asymptotes. Now, you're not going to have to necessarily be able to just state this from memory, but you are going to have to actually read your graph. So if we look at our vertical asymptotes, of course, a vertical asymptote always looks like this, x equals. Well, ours are at, I'm going to make a list, 0, pi, 2 pi. If we go backwards, looks like negative pi. So I'm going to turn this into a pattern. These graphs, it's all about just trying to find a pattern. So it looks to me like we have no fractions, so we know that it's pi times k. And k is an integer, meaning it can be positive, it can be negative, it can be 0, but what it cannot be is a fraction. Now, the domain. It's probably easier to state what the domain is not. So we would say x cannot equal pi k, right, our asymptotes, where k is an integer. We're trying to make this super generic. Now the range. Probably easier to state where it is rather than where it is not. So it goes from 1 to infinity. And then it also goes negative infinity. I did this backwards to negative 1. I did it upside down. It should really say, if we think through it, negative infinity to negative 1. And then there's a giant space. And then that joins up again from 1 to infinity. The zeros, and we're talking about the blue graph. Where does the blue graph touch the x-axis? There are none. And we're not really going to get super detailed into these descriptions, so we're not going to do increasing and decreasing. But that's basically the pattern for how these work. So that's going to make graphing the secant just a little bit easier. Because now you know what to do. It's basically the same idea. Now, tangent and cotangent will be a little bit different. So we're going to start by graphing, if this is secant, we start by graphing the cosine. So cosine starts high. At 2 pi, it ends at its maximum. At pi, it's at negative 1. And at pi over 2 and 3 pi over 2 at 0. And I would start there. Honestly, I would graph those points. Because those points are actually on the curve of the reciprocal, all of them. So all the zeros, I'll do this in blue. All the zeros, the reciprocal turns into zeros, or to asymptotes rather. The low point, that turns into this. A high point, and again, we only draw them where we have an asymptote. So 2 halves actually do make a whole, even though there's that giant space in between. If we wanted to continue this pattern on, it looks like the next asymptote would be at negative pi over 2, and this would go up. And 5 pi over 2, and this would go up. So the idea really is that you know that this graph looks like this. It starts with a half, ends with a half. All right, so that's really and truly what it looks like. The period here, of course, same as the cosine, which is 2 pi. Now, your vertical asymptotes, these are a different pattern. They all have, right, it's negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. So we know that it's x equals pi times k over 2. But k is odd. It's not, we can even say integer because that doesn't include 0. The domain here, again, probably easier to say what it is not. X cannot equal pi k over 2, where k is odd, because those are your asymptotes. The range are going to be just like what we just did, negative infinity to negative 1, and then we join that up again from 1 to infinity. Of course, where does it touch the x-axis? It does not. All right, so the last graph, the last 2 graphs that we're going to draw are tangent and cotangent. So this obviously is completely different. So we've not graphed tangent, but we'll graph tangent and then we'll graph the cotangent, which is of course the reciprocal. So if we take a look at, I'm going to go back to the unit circle if I can get myself together here. If we think about the unit circle, the tangent is 0 here and here, undefined here and here. It might help us to also talk about pi over 4, because it's 1 there. These are just numbers that are easy to graph. So pi over 2, pi, 3 pi over 2, these are important to be able to graph. So if we think about the point 0, 0, and put that on the graph, pi over 4 goes up to 1. That might be helpful. But pi over 2 turns into undefined. Pi over 2 turns into undefined. So the pi undefined, as we know, is definitely an asymptote. So the graph kind of jumps here. So it kind of starts back over again. So I'm going to go backwards. I'm going to think about what does it look like down here at negative pi over 4. At negative pi over 4, it runs downhill, so it's negative 1. And then at negative pi over 2 is down here. It's another asymptote. Now this is a straight line, or it looks like a straight line, but we know that when it hits the asymptote, it has to bend. So this is essentially your tangent curve. And because we want it to be consecutive parts, that's basically where it lives. It lives from here to here. So the period is just 1 pi. It goes from negative pi over 2 to positive pi over 2. We do not want this graph to start at 0, because then it's not continuous. It's like the two parts are split up. This is different than if you might think, well, we did that with the secant, but the secant had a continuous part in the middle. I mean, we had different things going on. So it's just different. So because we want it to be one continuous function, we are going to have this thing start at negative pi over 2, and that's important to realize. Also, when you go to graph this, I'm going to have you graph it for 2 periods, not just 1. So you're going to have to draw it for 2 cycles. So then if we continue this on, at pi, it's back to 0. At the pi over 4 is, of course, 3 pi over 4. That's right here. This is 3 pi over 4. So that's negative 1. And then at 5 pi over 4, we're back up to positive 1. And then at 3 pi over 2, it's another asymptote. So again, it just repeats. And this is what the graph looks like. So it's very important that you realize that it starts at negative pi over 2. And we're going to keep going back through this, but that's kind of tricky. What's also kind of tricky is that I'm going to lose that picture when we talk about this. So if we think about what we just did, the period we know is 1 pi. This is important and obviously completely different from the other 4. The asymptotes, they were at pi over 2, 3 pi over 2, they were at negative pi over 2, they were at 5 pi over 2. So you can see the pattern here is that x equals pi, k over 2, k is odd. The domain, much like the others, x cannot equal pi k over 2, where k is odd. Now here's what's really kind of important. The range is negative infinity to infinity. We can do anything with the tangent. Sine and cosine are very restrictive, but tangent can go negative 100, positive whatever, so we don't care. Now the zeros, I know we're not looking at the graph, but if you look back at the graph, the zeros were at 0. Of course, now I can't think, pi, 2 pi, negative pi. So the zeros are at integer values of pi. So your zeros are at x equals pi k, where k is an integer. So they do have x-intercepts, which is important. So now when we go to do the reciprocal, this is awkward at best. This is why you kind of have to know these. You kind of have to be familiar with that. Because what's going to happen, if you can picture this, and I'm going to draw it, if we start drawing tangent, so like we normally would do these, right? So here's my asymptotes, here's my zeros, and I would draw this. Well, now I have to do the reciprocal. So the reciprocal is, okay, asymptotes turn from zeros, asymptotes here these turn into zeros, and then it breaks the other way. This becomes a crazy mess. So it's really hard, if not impossible, to draw cotangent and tangent on the same graph. So it's going to involve a lot more thinking. So since these are the zeros, if we think about the reciprocal of a zero, that is an asymptote. So we have an asymptote at 0, an asymptote at pi, 2 pi, and we can stop there. These are the asymptotes, and the asymptote reciprocals become zeros. So we know those are the zeros. At pi over 4, you know that the cotangent is positive 1. And at 3 pi over 4, over here, right, we know that the cotangent is negative 1. So it breaks the other way. It starts high on the left and crosses over and goes low on the right. And so that is what the cotangent graph looks like. As far as the domain goes, that is 1 pi. Our range is negative infinity to infinity. Oops, I got that. It's not the domain. I read it, and sorry. It is the period that is pi. The vertical asymptotes in the domain, of course, go together. The vertical asymptotes are x equals pi k, where k is an integer. It's important that you kind of have a good grasp of these patterns. The zeros are, of course, our fractions, pi over 2k, x equals, where k is odd. So there's all of our parent graphs. We'll be going back over how to graph them in the next lesson. So now all you have to do is really be familiar with the parent graphs. The homework is really about the parent graphs. It's some matching. It's some easy questions about even and odd. You don't really have to draw any graphs. So give yourself a chance to sort of let this sink in.